All right, so in this video, we're going to factor the sum and difference of cubes, okay? We're going to use this first bullet point here, recognize and completely factor polynomial expressions using special factoring formulas, okay? We're going to do a couple extra videos here where we factor by grouping and where we completely factor, so where we put it all together, okay? Just a reminder, anytime you're factoring, you always want to check and see if there's a greatest common factor first, all right? If there is one, you want to take that out first. It'll make factoring easier, okay? So in these three examples, we're going to be factoring what we call the sum or the difference of two cubes, okay? You've already factored difference of squares. There was no factoring pattern for sum of squares, okay? With cubes, though, there's a pattern for each, and they're very closely related. You'll see the only difference is the signs in between the A and the B term here and in the middle term of this trinomial, okay? So if you've got the sum of two cubes, your binomial factor is going to be the cube root of the first term plus the cube root of the second term, okay? Now, from that, we're going to get our trinomial using these two values. So in my trinomial, I'm going to square the first term. I'm going to multiply these two terms together, a times b, and I'm going to change the sign, okay? So here, a times b was positive. I'm going to change that sign and make it negative, okay? And then the last term of my trinomial will be squaring b here, okay? Difference of cubes, same pattern, okay? That's the first sign here between the a and the b is going to be negative, and my middle term here, when I multiply a times b, negative b, I'm going to change the sign and make it positive, okay? So notice the middle sign here and here are different. Same thing with difference of cubes. Negative sign here, positive sign there, okay? So in this first problem, x cubed plus 8, you need to recognize first that both of these are perfect cubes, okay? So x cubed and 8 are both cubes. So to get x cubed, our a value will be x. To get 8, that's going to be 2 cubed, so our b value will be 2, okay? So we're going to plug these values into this pattern here. So first thing, I'm going to plug x and 2 in here for a and b. So my binomial factor is going to be the sum of those two, x plus 2, okay? Remember, our trinomial is going to come from these values in this binomial. So the first thing I want to do is I want to square this first term, this x. So my first term in my trinomial is going to be x squared. Second term in the tri, I'm going to multiply these two terms together. That gives me 2x, and I'm going to change the sign, make it negative, so negative 2x. And then the last term of my trinomial is I'm going to square b here, square the last term. 2 squared is 4. I can't factor either of these, so this is the complete factorization using the pattern for sum of cubes, okay? And that's it. If you want to check your work, you can use the distributive property, multiply this by times this tri, and what's going to happen, all the terms in the middle are going to cancel out, and you're left with x cubed plus 8, all right? Pause the video, give b a try. This is a perfect cube, this is a perfect cube, and they're separated by a minus sign. So we'd consider this difference of cubes. So try to factor using this pattern and then come back and check your work. All right, so our a value here is going to be 3x. So 3x times 3x times 3x is 27x cubed. So this would be considered the cube root of this term, okay? Cube root of 1 is just 1, so my b value is going to be 1. And I have a minus sign here, so we're going to use this difference of cubes pattern. So my binomial will be the difference of those two terms, 3x minus 1, okay? Reminder, our trinomial comes from this binomial. So I'm going to square this, 3x. When I square 3x, I get 9x squared. I'm going to multiply these two terms together. 3x times negative 1 is negative 3x. Change the sign, so I get positive 3x. And then square the last term here, and I get positive 1. So that's the complete factorization of 27x cubed minus 1, okay? Last one, again, pause the video, give this one a try. It's a little bit harder. There's actually an extra step here. So give it a try. Use difference of cubes first, okay? Pause the video and then come back and check your work. All right. When you were factoring this, maybe you thought, hey, this is a difference of two squares, and it is, okay? But we're working on difference of cubes, so that's the first step I want you to take here. And in all honesty, if you tried difference of squares here, it would actually add work to you. So the best way to factor this is difference of cubes. So remember, we want to use this pattern. First thing, let's find the a value is the cube root of the first. So the cube root of x to the sixth is x squared. The cube root of 64 is 4, okay? So I'm going to put these two together. Remember my pattern, it's going to be the a term minus the b term, so it's going to be x squared minus 4. My trinomial comes from this. Square the first term, that gives me x to the fourth. Multiply the two together, that's negative 4x squared. Change the sign to positive 4x squared, and then square the last. 4 squared is 16, okay? Hopefully you don't think you're finished though. Remember, we got to completely factor, all right? So hopefully you recognize that this is the difference of two squares. So we can factor that as x plus 2, x minus 2, and then this trinomial just continues. You can't factor this. You won't ever be able to factor this if you've done things in the correct order, okay? So this is the complete factorization of x to the sixth minus 64, okay?